going to cover the third section in conics, which is the ellipse. The ellipse is a flattened circle, or I think sometimes you guys use the term oval, although that's not a mathematical term. Here's what it looks like. Ellipses are used predominantly for orbits. Orbits of planets and moons. So, for example, the Earth actually orbits the Sun in an ellipse, not a circle. The Moon orbits the Earth in an ellipse, not a circle. Also, it's used for spacecraft. When we launch to, for example, Mars, we go in an ellipse to get there. And then finally, orbits of particles. For example, electrons orbiting the nucleus of an atom are in fact orbiting in ellipses again, not circles. How you create an ellipse is first of all, you have two what are called foci, which is the plural of focus. Remember that the parabola had one inside the ellipse. And what a focus means is the same thing it meant in a parabola. If you were to create or have a light here that shined off onto a mirrored ellipse, this would ricochet back to the other focus. So wherever you go, wherever you start, so you go in this direction, this will ricochet back to the other focus. So that's what a focus is. And an ellipse itself is created geometrically by making sure that the distance from one focus to the point on the ellipse plus the distance from there to the other focus is the same no matter where you are on the ellipse. So in other words, everything I've drawn here, that to there, if you add those up, is the same length as that to that, is the same length as that to that. That's how you draw one. Okay, now let's go to the equation. There's actually two equations, though they're basically the same, that we're going to go through. One is one for a horizontal ellipse. And this is one where the dominant part of the ellipse is on the x-axis. And the equation for that is x minus h squared plus y minus k squared. X minus h squared over a squared plus y minus k squared over b squared equals 1. In each of these terms, I'll talk about them before I write the next equation. hk is the center, just like it was for the circle. Notice this is always going to be 1. A and b are the spreads, what are called the spread of the ellipse in the x direction and the y direction. And you'll see in a moment, in order to make this ellipse horizontal, A must be bigger than B. Okay, now let's do the next one, which is the vertical ellipse. In this one, it's still x minus h squared and y minus k squared, and it's still 1. The only difference is that A and B are switched, like that. And again, A is bigger than B, which is what makes it vertical. Vertical just means it'll look like this. HK, should put that really above. HK is the center, just as in the other case. A, in this case, however, is the y direction of the spread. And B is the x direction of the spread. Now I think it seems, actually it looks like they're almost identical, and you might ask, why do you even bother to use a different equation? And why do you make A bigger than B and just switch the direction? The reason you do that is in this case, in the horizontal ellipse, the foci will be on this axis, and the equations for all the foci will be on that axis, the big axis. The center will be in the same place. But in this one, they'll be this way. So rather than switch all the equations for the foci, for example, and there's a couple other things we're going to do, you just switch the A and the B instead. Okay, But when you get these, you'll see in a moment, they'll just be numbers. They won't actually be A and B. So you'll have to decide which direction it goes. Okay, make sure you write that down. Pause it if you haven't written it down yet. And then I'm going to do some examples. Okay. If you're back to writing all that down. Okay, so I'm going to start with a simple one. X squared over 5 squared plus y squared over 3 squared equals 1. Okay, so the reason it's simple is just because the center is simple. The center, in this case, is simply 0, 0. There is no h and k. So I'll start by drawing that. Now I'm going to do the, first of all, a is bigger than b, so 5 is bigger than 3, which means this is a horizontal ellipse. And the x spread will, the number for the x spread will always be under the x. So this is 5. That means you go over 1, 2, 3, 4, 5, just like you did when you were doing a circle. 2, 3, 4, 5 with the radius. And then the number under the y is the y spread. So in this case, a is 5 and b is 3. So I go up 1, 2, 3, down 1, 2, 3. And that's all I'm going to actually use to draw the picture. If you could actually plug in values like you could put x is 3, put it in here, solve for y, and you will get points up here and down here. But I'm not going to do that in this case. I'm just going to draw it. There we go. And there's my ellipse. I haven't put anything points on it yet. I'm just doing the center and the spreads, basically. Okay, let's try another one. This time I'm going to have the center not be 0, 0. So let's see, I've got x minus 4 squared over 9 plus y minus 1 squared over 25 equals 1. Okay, so let's start again. Center. Remember to reverse them just like you did in the circle. This is x minus h, y minus k, so it's 4, 1. Positive 4, positive 1, not negative 4, negative 1. So it's 4, 1. I'll draw that first. The x spread, which in this case, this is bigger than this, so this one is actually b. X spread is 3. Remember, this is 3 squared. This is 5 squared, so a is 5. The number under the y determines the y spread, so I'm just going to draw that one first. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The one under the x determines the x direction. 3 and 3. And that's all I'm going to draw. And you can see this is now a, oops, here we go. This is a vertical ellipse because the bulk of it is this way. Now again, it doesn't seem like it's important which one's A and B particularly, except when you get to the equations of where is the foci and things like that. You'll see a bunch of different parts of this. Okay, I'm going to do one more, it's slightly different. 4 times x minus 1 squared plus 25 times y plus 5 squared equals 100. Okay, so first of all, this is not in the right form. It has to be 1 over here. So what I'm going to do is just divide by 100 to make it 1. And I'm going to divide the whole thing by 100. If I do that, this is 4 over 100, which is 1/25. There's 25 fours in 100. So this becomes x minus 1 squared over 25 plus 100 divided by 25 is 4. 4 y plus 5 squared equals 1. And now it's in the correct form. So I can look at this and I know this number is bigger than this, so it is a horizontal ellipse. The center is 1, negative 5. I'll graph that. 1, negative 5. The x spread is 5, which is the larger one. The y spread b is 2, which is the smaller one. So you go 1, 2, 3, 4, 5. 2, 3, 4, 5. 2, 2. This is a little thinner ellipse than the other one. And there we go. There's my, oops, should have been over 2. 2. There we go. Thinner ellipse than the other ones. Okay, we're going to do, actually I'll take it back. We're going to do one more just to show you how this is related to circles. Let's say I have x minus 2 squared over 4 plus y minus 2 squared over 4 equals 1. Okay, it does look like the ellipse form. Center is 2, 2. X spread is 2. Y spread is also 2. So what do we have? We have a circle. And that's because I could just multiply this whole equation by 4 and get this, which is a circle of radius 2, what we were doing a couple lessons ago. So what this means is, if A equals B, the ellipse equation becomes the circle. In other words, you don't really need the circle equation. It's just a special case of the ellipse. Okay, we're now going to go through and label a number of terms on these ellipses. So I'm going to graph another one. This time I'm going to do it on the regular board here. I'm going to define a bunch of terms that you use to define ellipses and draw them on a picture. So I'm going to start with the horizontal ellipse, and then I'll draw it small over here, just so I can define the terms. Oops, that was really poor. Okay, so the first is we have the center. We already described that. Then we have what are called the major axis of this. So I'm going to put it over here. I'll put the definitions over here. The major axis is the length of the ellipse where the bulk of the ellipse is. So in other words, if this is A, right here, 0 to A, let's say it's around 0, 0, this is A. The bulk of the ellipse is this way, as it's a horizontal one, and therefore the major axis is simply 2A, 2 times A. Okay, the minor axis is the other axis, the smaller one. Smaller axis, and that's equal to 2b. So that's the distance from here to here. This is b, and this is 2b. That's the major and minor axis. Center we already defined, that's HK. I'll put that here as well. And that's right here. H comma K. Okay, a couple more definitions. Vertices. Remember that the parabola had one vertex. This actually has 2 vertices. The vertices are the endpoints of the major axis. In other words, here and here, and they will be points. In this case, this one is A comma 0 and negative A comma 0. But it'll depend where the center is. It won't always be 8, 0. It's going to be out. So I can't really write a general one. I'll do it with some examples in a moment. The other vertices are here and here. Those are called co-vertices. And they're the endpoints of the minor axis. So in this case, because we're at 0, 0 center, this would be 0b, and this would be 0, negative b. Okay, the last piece is the foci, the thing I was talking about up front. There's 2 foci. Foci is the plural of focus. And they're the 2 points that basically create the ellipse. 2 points that geometrically create the ellipse. And they're also the points, as I said, where if you show light off of this onto this, it will go back at the other one over there. We're going to call those that length here, C, that distance from the center. And C, which is the distance of each from the center, so in this case it'll be plus C minus C, can be determined from C squared equals A squared minus B squared. I know that's confusing because it looks like the Pythagorean theorem. That is unfortunately just a notation that's generally used. So it is A squared minus B squared. And then I'll tell you where these 2 foci points are. Now the foci points aren't just useful for creating the ellipse itself. They are also, if there's an object creating it, like a gravitational object, for example, the sun, with the Earth orbiting it, is where the sun is. The sun is actually not at the center of the Earth's ellipse. It is off at one of the foci points. So this is not just an artifact of creating the ellipse itself. It is actually a physical thing. We are, the Earth right now is at the ellipse, or sorry, the focus point of, or one of the focus points of the moon as it orbits us. Okay, so now I'm going to do a couple more where we actually do all of these things. Oh yeah, one more. Sorry, before we go there. If we were to make this as horizontal, this is all for a vertical ellipse. Sorry, a horizontal ellipse. If we were to make it for a vertical ellipse, none of these equations or definitions change, which is why we flipped A and B. So let me just draw a little mini one over here. If you do this for a vertical ellipse, the foci are here, the vertices are here along the y-axis, not the x-axis. The co-vertices are on the x-axis, and the foci are along the major axis again. And that is all because you just switch A and B in the equation. You don't have to change any of these definitions. The major axis says the length of the ellipse where the bulk is. It's 2a. When this number is bigger, this is 2a, this way, even though it was this way in this case. Smaller one is 2b. Vertices are along the major axis, which is here. Co-vertices are on the minor axis, which is here. Foci are 2 points that create the ellipse. I didn't actually write that down, but they are also on the major axis. Okay, we're going to give some examples of that now. Erase all this. Pause it if you have to here to write that down. And I'm going to erase all this and just do a couple of examples where we go through these. So first I'll start with a simple one with it at the center. Okay, there's my ellipse. The center, I'll go through all these pieces of it. The center is 0, 0, because there's no h and k. So I'll do that first. The major axis, as I draw it, is the 100, which is 10 squared. So the major axis A is 10, and the major axis is 2A, which is 20. And I'll draw that in. It's along the y-axis, so it's 10 and negative 10. And then the minor axis, and by the way, you can see this is 20, which is right here. The minor axis, B is 7, so 2B is 14. 4, 5, 6, 7, 4, 5, 6, 7. So if I can count better than I did last time. And I'm going to draw that before I put the points on. Okay. Again, this is the major axis. This is where the foci and things like that are going to be. Okay, so now let's do vertices. The vertices are this point here, which is 0, 10, and 0, negative 10. Again, the points along the major axis. The co-vertices are 7, 0, and negative 7, 0 out here. Okay, and finally the foci. You have to do a calculation first. You have to do a squared, c squared equals a squared, which is 100, minus b squared, which is 49. Again, the reason to switch a and b is this will always be positive. That gives you c squared is 51, or c is radical 51. And let me get that and put it as a decimal just so we can graph it. It's c is 7.14. What that means is that the foci is up on the y-axis, 3, 4, 5, 6, 7.014, or 7.14, and down here as well, 1, 2, 3, 4, 5, 6, 7.14. Here's my first focus, here's my second focus. And my points are 0, 7.14, and 0, negative 7.14. Okay, so when it's around 0, 0, it's pretty straightforward. All the points are easy to get. I'm going to do one more. I'm going to do maybe one or two more where we actually move the center and therefore all these points, and they're a little harder to get. I'm not going to erase all this stuff though, because this will all stay the same. I'm just going to change the equation. Okay, so let's start with the equation of x minus 1 squared over 25 plus y minus 2 squared over 9 equals 1. Okay, the center is, let me erase this out here. The center is 1, 2. The major axis, we're going, let me just draw it first actually, where this is 5 squared. So we're going along the x-axis 5, 2, 3, 4, 5, 5, and the y-axis is 3 and 3. Draw a crude graph here. It's hard to make these not look like potatoes. Okay, so there's my graph. Now I'm going to get the numbers. The major axis is now horizontal. This is horizontal, not vertical like the last one, because this number is bigger than this number. Therefore, this is a squared. So 2a is this distance here. It is 10. 2b is this distance here. It is 6. The vertices, there are equations for them, but they're not really that useful. Just take this point now you created as your vertex over here and see what it is. It's 1, 2, 3, 4, 5, 6, 2 is one of them. And the other one is at 1, 2, 3, 4, negative 4, positive 2. And you can actually see if you get the difference between 6 and negative 4, you get 10, which is the major axis. The covertices are up here, 1, 5, and 1, negative 1. And finally, the foci you have to calculate. It's going to be c squared equals a squared minus b squared. And again, a is the bigger one, so this is never negative. 25 minus 9 is 16, and c is just 4. So c is 4. So you count over 4 along the major axis. 1, 2, 3, 4. 1, 2, 3, 4. Here's F1. Here's F2. You can label them any way you want. And this is 5, 2 for that focus, and 3, negative 2 for that one. Okay, so again, just do them visually. There are equations, and they're in the presentation for these, for the foci, for example, where you get the points and the covertices and the vertices, but they're not actually very useful. Just plot the center, count the and then plot it out. Get the vertices from here, the covertices from here, and just pull them off the graph. Okay, let's see. We'll do maybe one more example. Again, let me erase all this stuff. Actually, why don't you just try this one on your own, and then come back to see what the answer is. Let me write the equation up. X squared over 25 minus y, plus y minus 2 squared over 36 equals 1. Okay, pause the video and get all of these things and graph it. Okay, if you're back, center, 0, 2. So I'll do that first. The y-axis spread is bigger this time, so it's going to be a vertical parabola. And it is 6, 2, 3, 4, 5, 6, and 6. The x spread is 5, so 2, 3, 4, 5, 2, 3, 5. Graph that. It's a fatty one this time. Okay, now major axis is twice that, 12. Minor axis is twice that, which is 10. Vertices, I'm going to count them out. Vertices are up here, so it's 0, 8, looks like, and 0, negative 4. The covertices are out here, which is 5, 2, and negative 5, 2. The foci, first I get c. C squared equals 36 minus 25, or 11. We need radical 11 to get c. 3.32. So you go 1, 2, 3. Again, it's along the major axis, 3.32. And 1, 2, 3.32. And that's my F1 and F2. And my foci, therefore, are 0, was that 5.32? The 2 plus the 3.32, and then 0 and negative 1.32. Okay, I'm going to do one more problem. I think this might only be relevant to college algebra rather than the geometry, but yeah, worth looking at either way. This time I'm going to, instead of giving an equation, just getting the parts of it, I'm going to give you some of the values and you're going to have to come up with the equation. So I'm going to say the focus is at negative 5, 0 and 5, 0. And the vertices of the parabola, sorry, the ellipse, are at negative 8, 0 and 8, 0. And the question is, what equation do we have? The way you do this is actually just graph the points. So 1, 2, 3, 4, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. 8 and negative 8. You can tell from that probably already that the center is at 0. The foci is at 5, 0, which is there. And negative 5, 0, which is there. The difficulty is I don't have b. And what you have to do is use the focus and the vertices to find b. So I do know the equation looks something like this. X squared over, actually I don't even know. Yes, I do know. This is a horizontal ellipse because otherwise those points would be there. So I do know that it's x squared over 8 squared. And I know it's y squared. I don't know what's over b squared though. And that's equal 1. I do, however, know the focus is 5 away from the center. So I use my equation, c squared equals a squared minus b squared. In this case, I know a squared, it's 8 squared. And I know c squared, it's 5 squared. So this is 25 equals 64 minus b squared. And now I can solve for b. So I'll subtract 64. That is negative, what, 39? Negative b squared, or b squared equals 39. Go back to the calculator to get radical 39 is 6.24. So that means that this is 6.24 squared, or actually more easily, 39. That's 64. And now I can graph that. 6.24 is 1, 2, 3, 4, 5, 6 and a quarter, roughly. 1, 2, 3, 4, 5, 6 and a quarter, roughly. And there is my drawing and my equation. All right, that's it. Erase this here. I'm going to put down the homework now. The homework is basically just graphing of these things and getting the equations from the graphs. So for geometry, just do the ellipse worksheets, no book homework. For college algebra, do homework number 30, which is called ellipses. All right, that's it. Thanks. Until next time.